Welcome to my video on estimating a confidence interval or the estimate of a population proportion, one population. Here's the formula we'll be using if you are asked to estimate the percentage of a single population or the proportion of a single population. Here, you are trying to find a confidence interval or an estimate of P using P hat. So we're going to be using the sample percentage or proportion, which is P hat, to estimate P, which is the actual population proportion or population percentage. And this is the sample proportion or population percentage. So we're going to be using the sample to calculate an estimate for the actual population percentage. So if you don't know the percentage of US population that owns an iPhone, you randomly select, 5,000 of them, and based on the results you get from the 5,000, you can make an estimate about what the actual percentage of iPhone owners are in the entire country using this formula. It's crazy, but it works. God bless the mathematicians that came up with this whole idea. Now, sometimes P hat will be given to you, sometimes not. So if I say the sample percentage, let's say is, 32%, that means I've given you P hat, and that's 32% or 0.32. And sometimes instead I'll say X is 17 and N is 85, and here you have to find the sample percentage yourself by dividing part by the whole. So there are two scenarios in the exercises that you'll see this problem emerging. I will either give you the sample percentage, which means you have P hat, you just have to plug it in, or I'll give you X and N and you have to divide them to get P hat. So those are two different scenarios that you could see. And that's it, there's no other way. So I'll either give you P hat and you use it to estimate the P, or I'll give you N and X and you divide them and get P hat and then use it to estimate the P. So let's look at a problem here with you guys. So here it says each year billions of dollars spent in theme parks. A survey of 1,233 people that took a trip revealed that 111 of them visited a theme park. So here's probably some travel agency trying to find out what percentage of people visit theme parks to know whether they should invest a whole bunch of money on creating like theme park uh, side action for their holiday packages. It's asking us to construct a 95% confidence interval estimate of the percentage of all the people that visited the theme park while they were on their holidays. Now, so you want to find estimate the percentage. So I could see it here if I make that red, highlighted in red. Let's see, estimate the percentage. So that's how I know that they're asking me to estimate the percentage, and that's how I know this is the formula I have to use, because this is the only formula that estimates the percentage of a single population. So now in order to do this, you realize I need to know what P hat is, I need to know what Q hat is, I need to know what N is, and I need to know what Z is. So I need to know those four values so I can then plug them in and find the left hand side or the lower confidence limit, and find the right hand side, also known as the upper confidence limit. Well, you see, this is a problem where P hat's not given. It tells you there's 111 of them out of 1233. So this is like a part divide by total type situation, which mathematically and that's P hat. Mathematically, you say X over N. So that's how you find P hat on Excel, and then your Q hat will be 1 minus P hat. Now it says 95%, so you will find the z-score for 95%. Now we all know the z-score is the alpha over 2. That's just the symbol, by the way, alpha over 2. That z-score, that's just the symbol they use to write. It's basically the z-value for 95% is 1.96. But you could also do it with the command. Remember, the command was equal to norm.s.inverse. And the probability that you put in here is you have to take, I'm sure you remember, you have to take the confidence level, you have to divide it by 2, and you have to add a half to it. So I have to take 0.95 divided by 2, and then add a half to it, and that's the value I will use in here to find the z-value. And if you do that, you get 1.96, and my sample size n is 1233, so my p hat is 111 over 1233. Q hat's 1 minus p hat, and z is 1.96, and then you have all of it to plug in. Now, if I show it to you on the next page that I've done it for you guys, see, that's how we do it. Now, I've used another value of some other way of doing the normal distribution. You could try this, but and you get 1 point, you get minus 1.96. Either way, there's so many different ways to find a normal distribution value, the z value from it. But I've just given you guys different ways of doing it, but I wouldn't type that. I just go with what I initially told you, which is the confidence level divided by 2 plus 0.5. And since the confidence level here is 95%, I'll show you how that works out on Excel. You could use 0.025, but I would just use 4. I'll give you the same answer. So if I go to a spreadsheet and you want to figure out the z value for 0.95, so the confidence level is 95%, so you do 95% divided by 2, so equals 0.95 divided by 2. And then you take that and add 0.5 to it. And that's the number we use to calculate the normal distribution. So I type equal the z value for the normal distribution. So norm dot s dot inverse open parentheses, and your probability will be 0.975, and the answer is 1.96. So that's how you can get 1.96. So instead of the value you see over there, 0.025, you should use 0.975. It's the same thing, but that's a better value to use. So you get 1.96, and remember, it's always plus minus because you use it on both sides of the formula, but you don't need to worry about the plus minus. You just have to just use the value itself on both sides. The formula takes care of the plus minus. So x is 111 and it's 1233. You divide them, you get 0.09. Of course, you're doing this on Excel, so you don't have to worry about how many decimal places to write. So you just write everything on a spreadsheet and click on it. Remember, when your ratios and divisions create a lot of decimals, it's not a good idea to just write the numbers in the formula. Just click on the numbers. The only time you could actually use the number itself is if no decimals or just one decimal place, and you know it terminates. So if you got a nasty divisions and stuff, just do them on Excel and click on them to capture the entire number, because if you just write the first 3 decimal places, your answer may not match mine because I might have chosen 6 decimal places. So try to do this on Excel, and I will show you how to do it. And I've shown you how to do it on my Excel video, but I'll show you how to do it here as well. So you plug all that into this formula, and I've shown them here to you. You plug them all in, and that's the answer you get. Of course, during the exam, I'm interested in just these 2 numbers. And all you have to do is type the lower confidence limit and the upper confidence limit. But I'll go ahead and share with you how this is done on a spreadsheet. So clear this up. 111, 1233. So x is 111 and is 1233. So p hat, and then I also need q hat, and I also need my z value. And once I have that, then I can compute my lower confidence limit and upper confidence limit. Well, my z-score I already showed you, it's 1.96. My p hat is x divided by n. You see, it's a whole bunch of decimals. So if you write 0.09, you're missing a whole bunch of numbers. Equals 1 minus that. And you can't write this. So how many? Let's say there's 5,000 decimal places. What are you going to do? Write 5,000 decimal places? So this is best for you to just do this on Excel and not write it and just click on it when you need it. Like when you want to calculate the lower class limit, you say equal to p hat. So you just click on it. You don't write 0.09. I wrote 0.09 on my PowerPoint so you could see where I'm plugging it into, but I didn't actually plug in 0.09. I plugged in 0.09002433 blah blah blah. So click on the number to capture the whole thing. Otherwise, you're going to get a different answer than I do, and then you're going to lose points. So p hat minus the z-value times the square root of p hat times q hat divided by n. And that will give me the left-hand side of the lower confidence limit. And the other side, same thing, p hat, but this time plus the z-value times the square root of p hat times q hat over n. And that will be the right-hand side. And you'll notice it's the same answer you get on the PowerPoint. So let me go back, and that's the value you get for computing or estimating the percentage of a population. Thank you.